Okay, so today we're going to talk about complex numbers, okay? So complex numbers come from imaginary numbers, which we'll talk about in just a second. So define a real number. That seems like so vague. What's a real number? It's just any number, right? Well, that's kind of a weird definition, but any number is a real number, right? I mean, you can think of any number. So I saw this a long time ago, and I like this. Any number that can be found on the number line. Okay, I like that. I mean, pi, right? Can be a real number. Square root of 2, 2/7, -5. You know, you name a number, it's a real number, right? Those are real. We can use those. We can find those on a number line. But an imaginary number is not on a number line because it doesn't exist. It's imaginary. So it starts from this concept of the square root of -1. In fact, if you tried that on your calculator, it's not going to work. Square root, -1, doesn't like it, right? It says non-real because it is not real. So we have to deal with it. So we say, okay, well, we're going to call it I, and I is defined as an imaginary number, okay? Another thing that's helpful for us is if we squared both sides. This will come in handy later. If we squared it, then we know that I squared is equal to -1, okay? So I'm going to highlight that because that's going to come in handy later, okay? So we go from a number that's imaginary, doesn't exist, to a real number when we square it, okay? So I squared is -1, okay? Now, complex number, it's complex. It's like a crazy relationship between a real number and an imaginary, okay? That's a complex number. It has a real, and it has an imaginary. All right, an example, that is a complex number, right? That would be a complex number. It has a real 2 plus 3i. That's a complex number, 4 plus 5i. It's really pretty simple, okay? So let's go ahead and do this. Let's take a look. Example 1, you cannot take the square root of 25, but what you can do is rewrite it as the square root of 25 times the square root of -1. Now, if you've already jumped to the answer, good for you, awesome, I'm glad. I'm just going to do things, because I'm the teacher, step by step by step. Well, that just becomes 5i. You guys okay with that? Thumbs up? Does that make sense? 2, I've got to do a little simplifying. I'm going to rewrite this as the square root of 9 times the square root of -1 minus 2 square root of 25 times the square root of -1. Which is a 3i minus a 2 times a 5i. I got the square root of 25 is 5. There's my I. Which is a 3i minus 10i. Which is just a -7i. Okay, those are imaginary numbers. They're not even complex numbers yet. But if we take a look at number 2, that's a complex number. So we add reals with reals, imaginaries with imaginaries. It's that easy. Reals with reals, we're going to go 4 plus 2 is 6. Plus 3i plus 5i is 8i. Boom. Done. Simple. Now 4 is going to have a trick in it, but we're smart. We'll see it. Okay. 4 is going to have a trick in it. So let me go ahead. I'm going to FOIL it or double distribute, right? I'm going to go 3 times 5, 3 times -3i, 2i times 5, and 2i times -3i, right? I'm just going to FOIL it out, multiply it out. So 3 times 5 is 15. 3 times a -3i is a -9i. 2i. You okay with that? 3 times 3? 2i times 5 is a positive 10i. And then 2 and 3 makes a negative 6i squared. Hold on. Hold on. Didn't we say that I squared was negative 1? So when you see I squared, we're just going to change that to negative 1. Whenever you see I squared, we just change it to negative 1. So let me rewrite this. Got a 15, and I'll put these two together because they're the same, plus a 1i, right? Minus 6 times a negative 1, because I'm going to rewrite my I squared as negative 1. Am I going slowly enough? Okay. That's going to be a positive 6. And then we're going to go 21 plus 1i. You don't really need the 1 there, but I put it there anyway, okay? So the rule is, and I would never mark it wrong, but the rule is real goes first. Does that make sense? Real plus imaginary. I mean, if you wrote it the other way, it's still, I would mark it wrong, but the rule is, put the real, then the imaginary, okay? All right, number 5. I have the square root of negative 25 over the square root of 50, okay? So one of the things I can do is this. That is going to be a 5i. You okay with 5i there? Over, well, let's see. I'm going to do a little work on the side here. Let's see. Square root of 50, same thing. Square root of 25 times square root of 2, right? You okay with that? If I do a little side work on the side. So we've got square root of 50, same thing, square root of 25, square root of 2, square root of negative 1, right? So that's going to make a 5 square root of 2i. I can cancel some things, can't I? I's cancel with i's, 5's cancel with 5's. And I'm left with 1 over the square root of 2. Okay. Now that answer is acceptable, but it's not nice. Depends on your math teacher in college, right? We may have to rationalize the denominator. Do you remember doing that at all? Zoe remembers, right? Remember rationalizing the denominator? Because we did in geometry and algebra, okay? So you can't have a square root in the bottom. So a better answer is the square root of 2 over 2. That's a better answer. Remember doing that in Algebra 2 at all?
Oh, no. That was really early.
Remember doing that at all? Can't have a square in the bottom? So I fixed the problem with the problem? Okay, we'll come back to that. Number 6. Well, there's all these silly rules in math. They are real rules, but they are kind of silly. One is you can't have a square at the bottom, right? And so we fixed it. And the way I teach this when you guys are in geometry is I say you fix the problem with the problem, right? So I multiply by square root of 2, square root of 2, and I wound up with square root of 2 over 2. Well, because square root of 2 over square root of 2 is square root of 4. Square root of 4 is 2, okay? But that takes us back to geometry. Well, the same thing here. You can't have an I in the denominator. It's just a silly rule, but it is a rule. So you fix the problem with the problem. So if I multiply by I over I. So you fix the problem with the problem, okay? The problem is you can't have an I in the denominator. So how's that going to help us? Well, let's check it out. I'm going to get a 7i over 2i squared. Tell me, how's that help me? Tell me, how's that help me?
Whenever there's an I squared, it's just negative 1.
So there's no longer a square or an I in the denominator. You guys agree with that? Good job, Spencer. So I wind up with 7i over negative 2. And that's the exact same answer, but then we don't have a negative. We don't have an I in the denominator, okay? All right. I to the 7th. So I want you to write a couple of things down. Right here, a little side work. So we know that I, the square root of negative 1 is I, right? We know that. We also learned that I squared is the same thing, I squared is the same thing as negative 1, right? We learned that, right? I showed you how, okay? So then that means that I to the third should be a negative 1i. Because it's just this times this, right? I to the third has got to be negative I because just these two multiply together, right? Which makes a negative 1i, okay? But then I to the fourth is a positive 1. Well, because I to the fourth is I squared times I squared. I to the fourth is I squared times I squared. Negative 1 times negative 1 is positive 1, okay? How does that help? Okay, so I to the seventh. Here's what I want to do. I like I to the fourth. I'm going to highlight it. I like I to the fourth. I like this a lot because it just becomes negative, it becomes positive 1. So I'm going to rewrite I to the seventh as I to the fourth times I to the third. I want an I to the fourth. I want an I to the fourth because I to the fourth is 1. And I to the third, we said was negative I. Okay, I to the fourth was 1. I to the third, we said was negative I. So we wind up with an answer of negative 1i. So I to the seventh and negative 1i are the exact same answer, but it's reduced. It's been reduced. We find as many I to the fourths as we can. Okay, so let's look at 8. So I'm going to write it as I to the 24th times I squared. Whoa. I to the 24th. Why did I pick I to the 24th? Anybody? Why would I pick I to the 24th? You ready? Come on. Will you count for me? You ready? I to the 4th. So give me 1. I to the fourth. I to the fourth. How many I to the fourth I close so far? All right. Okay. Ready? So 24 is I4, 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 isn't it? I to the 24th is I4, I4. I'll write it out so you guys can see it. Okay. So my goal is always, always, always to get I to the fourth. Okay. I want I to the fourth. So this is I4 times I4 times I4 times I4. 1, 2, 3, 4. I4, I4, and I got left over an I2. It's kind of squished in there. So I normally would never do it this way because hopefully you guys are going to say, wait a minute. You ready? 1. 1 times 1 times 1 times 1 times 1 times 1. Got the idea? Which one's faster to lie than 24? Because we know that's a whole bunch of 1s, isn't it? See where I'm getting at? So that is 1. Isn't that 1? The number 1. That's just plain old number 1. So I'm looking for a multiple of 4. A multiple of 4. So this, which is all of these, is 1. We get 1 times 1 times 1 times 1 times 1 times 1. So I get 1 times I squared. I squared, which makes 1 times negative 1, which is a negative 1. So if we were to simplify I to the 26, it's really just negative 1. Okay. I to the 9. Oh, we got a negative exponent. Oh, that's 1. Remember that's 1 over negative exponent? You guys remember that? Hopefully, maybe. I know last year was a blur, but anything with a negative exponent should be made into a fraction. So it's 1 over I to the 10th. Okay. Now let's break up I to the 10th. What do you guys think would be a good choice? What would you break I to the 10 up into? We need I to the fourth. I want I to the fourth, so what are you going to make I10 into? 8 and 2. Okay, because that makes 10. But why does Nina like the 8? Because that's just 1 times 1, isn't it? So we wind up with 1 over 1. I don't really need to write the 1, but I will. Times I squared. But what's I squared? Negative 1. So my answer is just negative 1. So out of the negative 10, that's a nicer answer, isn't it? Negative 1. Okay, how am I doing? Okay, return the page. All right. So what I did is I said we can't have I in the denominator, okay? So can't have I in the denominator. Right? And when I did it over here, I just fixed the problem with the problem, right? I can't have I in the denominator multiplied by I over I. But that's not going to work this time. It's not going to work. Because if you multiply by I over I, and I'll show you on the board, but don't write this down. Don't write this down, but let me show you the problem is, it's not going to work. If I multiply by I over I get a 3I over 4I plus 2I squared, right? That goes away. That goes away. That one doesn't. So you're still stuck with I on the bottom. So what do? Well, we're going to multiply by a thing called the conjugate. Fancy word. I don't care if you remember the word. I'm going to write it down. It's called conjugate, okay? So, the conjugate is the opposite. We only do this if we get a plus or minus. The conjugate, we only multiply by the conjugate if we ever have a plus or minus. Okay, so I'm going to multiply by 4 minus 2I. And I have to do top and bottom the same because it's called the rule of 1. But I do top and bottom by the same because it's called the rule of 1 because I'm multiplying by 1. Okay, it doesn't change the value. How's that going to help me? Well, let's check it out. How's the conjugate going to help me? So, in the numerator, 12 minus 6I. I don't care if there's an I on the top. Top's okay. In the denominator, here's why the conjugate works. 16 minus 8I plus 8I minus 4I squared. Okay? All right, before I go on, do you see how the i's are going to just disappear in the bottom? Do you guys see how the i's are just going to disappear in the bottom? Because these two cancel. That will always happen by the conjugate, and this becomes a negative 1, doesn't it? So I'm going to have a 12 minus 6I over a 16 minus 4 times a negative 1. Which is going to be, I'll scoot it over here so I have more room, 12 minus 6I over 20. Can you see the 20? Negative 4 times, that's a 16 plus 4, right? And now here's the deal. If you give me this answer, I would never mark it wrong. But it should be 12 20ths minus 6 20ths I, because they're supposed to be separated, because that's my real number and that's my imaginary. If you don't do this, I would never mark it wrong. And I can actually even reduce this. I want to get fancy. Reduce that. Reduce by 2, and I get 6 tenths, 4, and I'm going to get 3. Let's see, reduce by 4, and I get 3/5, right? Minus a reduce by 3, and I'm going to get a 2 tenths, right? 1/5. Golly, I can't reduce. Okay, 2. Let's see, that's going to go in there. 4 divides in there is 5. Nope. Nope. Probably just 2. I'm going to get 3 tenths. I. There we go. Come on, help me out, you guys. Okay, now 11. Divided by 4. Okay. So same problem. We're going to multiply by the conjugate. Which is going to be a 5 plus 3i. That's the conjugate, okay? We multiply both top and bottom by the same because it's called the property of 1. Okay? It's a little bit bigger of a problem, but the same type, okay? Let's see how that works. Can't have an I in the bottom. So I'll FOIL the top, or the numerator. I'll get 15 plus 9i plus 10i plus 6i squared. Okay? In the denominator, I'll get 25 plus 15i minus 15i minus 9i squared. Okay? Step back for a second.
Would it be plus 9 squared?
I got the negative times positive. It will become plus so eventually, Spencer. It really will. Because that'll become a negative 1, right? So here's what I'm going to do. I know those two cancel. They always will. The middle two terms will always cancel. And that becomes a negative 1. And this I squared becomes a negative 1, okay? So let's see what kind of mess I have. All right, I'm going to have a 15 plus a 19i minus 6 over a 25 minus 9 times a negative 1. Spencer, there's your plus 9, right? Okay, this is going to be a 9 plus a 19i over 25 plus 9. What's that, a 34? I'm going to get a 9 plus 19i over 34. And I'm going to rewrite it as 9 34ths plus 19 34ths I. Okay? And that's all I can do with that. Come on, stop. Stop recording. Stop.